Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of derivatives. So the following graph represents the derivative function prime of f at x of a function f at x. Determine the intervals where f at x is increasing, the intervals where f at x is decreasing, and x coordinates for all local extrema of f at x. Assuming f at 0 equals 2, make a rough sketch of graph of f at x. So we have to analyze this given graph for prime of f at x to sketch the graph of f at x. Now we can see that this graph is a parabola that opens downwards, and this parabola has two x-intercepts. So the first x-intercept is at x equals -2, and the second x-intercept is at 3. Now to the left side of the x-intercept -2, the graph of prime of f at x is below the x-axis. So that means to the left side of -2, prime of f at x is less than 0 because the graph is below the x-axis. Now between -2 and 3, the 3 is the other x-intercept. Between -2 and 3, the graph is above the x-axis. That means between these two x-intercepts, so prime of f at x is greater than 0. And to the right side of 3, the graph is below the x-axis. That means in that part of the graph, the prime of f at x is less than 0. So now we can use this information to find the increasing and decreasing intervals for function f at x. So let's start with the increasing intervals. So as we know, a function increases in intervals in which prime of f at x is greater than 0. So in this case, that interval is from -2 to +3. So in interval notation, we can write that as -2 to 3. Now in the inequality notation, we can write this as x is greater than -2 and less than 3. So in this case, there is only one interval over which function f at x is increasing. Now we can write the interval over which the function is decreasing. And those are intervals in which prime of f at x is less than 0. So the first interval in which prime of fx is less than 0 is all points to the left of -2. So in interval notation, we can write that as -infinity to -2. And there is another interval over which this function is decreasing, and that's the part to the right side of the x-intercept 3. And that can be written as 3 to +infinity. Now in inequality notation, we can write these intervals as x is less than -2 and x is greater than 3. So these are the increasing and decreasing intervals for f at x. Now we can find the x coordinates for all local extrema of f at x. Now the local extrema are found at points where the sign of f at x changes. Now in this case, at the x-intercept -2, as we go from left to right, so prime of f at x changes from negative to positive, because from left to right, the graph goes from below the x-axis to above the x-axis. So that means the function is changing from decreasing function to increasing function. So there is a minimum at x equals -2. So there is a very important concept you need to understand and memorize. Now we should analyze the second x-intercept of the graph of prime of f at x. So at this x-intercept, the graph goes below the x-axis from left to right. So that means at this x-intercept, the function f at x changes from increasing function to decreasing function. That means there is a local maximum at x equals 3. So now we can use all of this information to sketch f at x. Now we are given a point that lies on the function f at x, so that's 0, 2. So this point lies on the y-axis. So now we have to analyze the behavior of the function f at x around it, local max and local minimum. So there is a local minimum at x equals -2, and between -2 and 3 the graph is increasing. So we want to show the local minimum below the point 0, 2, so that we can show the graph going up between -2 and 3 and passing through that y-intercept. So we can show the point here. So on the left side of this point at x equals -2, the function is decreasing, so the graph goes up to the left side. So as we go from left to right, so we can see that all tangents we draw to this graph have a negative slope, so the function is decreasing from -infinity to -2. Now the function has to increase from -2 to x equals 3, so that means the graph has to go up and it should pass through this point on the y-axis. So we can show it like this, and then we can make it pass through that point, and at x equals 3 there is a local maximum. And to the right side of x equals 3, the function is a decreasing function, so that means the function has to turn back down. So this can be a possible sketch for f at x. So these are the steps you have to keep in mind to sketch f at x from the given graph of prime of f at x. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.